All right, students, it's Friday, so that's another day for problem solving sessions. And I'm picking chapter 6, problem 54. That's partly because we're getting into gas laws, and I want to make sure you guys are working on some of those problems. So I picked one for the earlier types of problems to work on. I'm going to go ahead and turn off my video. I just wanted to say hi to everyone and let you know I'm here. And I'm going to walk you through this particular problem. So in problem 54, the question reads, use the molar volume of a gas at STP to calculate the density. And because it's a gas, the density, unlike solids, liquids, which are grams per mil, the density of gases is grams per liter. And this is of nitrogen gas. So again, density is mass over volume. But for gases, because the majority of the space that they occupy is empty space between the particles, there's not a lot of mass, so we have to do grams per liter for density. But let's go back to the question. Use molar volume of a gas at STP to calculate the density of nitrogen at STP. So first, molar volume of a gas at STP. Well, it's probably useful to know what STP stands for. And STP stands for standard temperature and pressure of a gas. It's a set of conditions we can use to help us with stoichiometry and calculations and to develop conversion factors to help us convert things to moles. Just like molarity with solutions allows you to convert moles from liters, or molar mass allows you to convert for solids grams to moles. Molar volume allows you to convert moles from liters as well, but we have to have standard conditions. And those standard conditions are 0 degrees Celsius, but with gas laws, we're always using the absolute temperature scale, and that's why really it's 273.15 Kelvin and a pressure of 1 atmosphere. And we know that the molar volume of any gas, it really doesn't matter the gas, 1 mole of any gas at STP occupies the same volume. And that's because whether it's helium or xenon or methane or any gas, the size of the actual particle is negligible to the volume it actually occupies, because the volume is really influenced by the number of collisions like you watch in those videos, and that's directly proportional to the number of particles colliding to the walls of the container. So it doesn't really matter the size, it matters the number. So 1 mole of any gas at STP, right, occupies 22.4 liters. So the molar volume of nitrogen is, well, 1 mole of nitrogen is 22.4 liters at STP. The other thing is we need to remember that nitrogen gas is one of the diatomics, okay? It's N2. Remember the acronym Brinkelhoff. Now that's going to be important in a second here. So now that we know molar volume STP, set of conditions, 0 degrees Celsius, 1 atmosphere, and any gas occupies 22.4 liters if I have a mole of it at STP. I need to figure out what density is. Well, they tell me. The density is the mass of the gas per volume, but the units are grams per liter, not grams per mole. The nice thing is molar volume gives me the units of liters, right? So how am I going to convert the unit of moles to what I need, which is grams? Well, we've been learning this all along. We know it's nitrogen gas, and we know the molar mass of nitrogen gas. 1 mole of nitrogen is 28.02 grams. So this goes all the way back to chapter 3 and 2, where we learned molar mass. It allows me to go from moles to grams. And it is critical to make sure that I know nitrogen is a diatomic so that I get the correct molar mass of 28.02 grams per mole, as opposed to making the mistake and only writing 14.01 if you thought it was just a monoatomic element. So now that I have the molar volume and the molar mass, I can actually get my units that I need. I can get the grams and I can get the liters for density. And how do I do that? Easy. I take the molar mass and I multiply by molar volume. Now you can interchange this. It really doesn't matter because the units are going to cancel, but you're still going to be left with density, which are these units of grams per liter. So what does that look like? Well, again, molar mass is grams per mole. And we'll plug the numbers in a second, but that's basically what molar mass is. Grams per mole. How many grams something is per mole. Molar volume is how many liters per mole. And because it's at STP, it's a set amount. And we know that set amount. It's right there. So now we can plug in the numbers and we see, well, the molar mass of nitrogen gas is 28.02 grams per mole. 1 mole of nitrogen gas at STP is 22.4 liters. And then I see my unit of moles cancel, and my final answer is 1.25 grams per liter of nitrogen gas at STP. So molar volume is a very useful conversion factor that allows us to solve for density. So I hope you enjoyed this problem-solving session for this Friday. As always, if you guys have any questions, feel free to email me directly, set up the questions on Ask a Question discussion board, or hopefully I'll see you in office hours. Take care.